Welcome to the August Nebraska Extension Dairy Webinar Series. I'm Kim Clark, Dairy Extension Educator here in Nebraska. I have the opportunity to work with all the dairy producers across the state. And today I am joined by our guest speaker, Dr. Rick Koelsch, who is in the Biological Systems Engineering Department and the Animal Science Department at UNL. And Dr. Koelsch will be talking about transforming manure from waste to worth. As we get started today, first I just want to thank our sponsors for this opportunity for this webinar series. We have the Nebraska Corn Board, Alltech, Automated Dairy Specialists, DCC Waterbeds, the Nebraska State Dairy Association, and Balchem. As a reminder, this is the monthly webinar series on the second Tuesday of every month. So our next webinar will be Tuesday, September 8th at 11 o'clock in the morning. And Dr. Amy Schmidt with UNL Biological Systems Engineering will be talking about mindful manure management. So providing some tips for staying safe during manure application season. Just also as a reminder that this presentation cannot be recorded in any form, and the materials cannot be used without the expressed authorized permission of myself or the presenter today. And with that, I will introduce our speaker for today. One thing you'll notice at the bottom of the slide is a go.unl.edu/dairy manure link. Feel free to click on that link or type that link into your URL. The slides along with some notes from today's presentation will be found there. As you're doing that, I'll introduce our speaker, and our speaker today is Dr. Rick Koelsch. He's a professor at UNL in two departments, the Biological Systems Engineering Department, as well as the Department of Animal Science. He received his bachelor's degree in 1975 and his master's degree in 1977, both from Kansas State University. And in 1992, he received his PhD from Cornell University. In 1995, Dr. Koelsch joined faculty at UNL, and since his time at UNL, he has received numerous awards and honors, and he has published many papers in peer-reviewed journals. Dr. Koelsch's areas of expertise include sustainability of agriculture systems and animal manure management. Thank you, Dr. Koelsch, for joining us today, and we're looking forward to your presentation. As Dr. Koelsch is sharing his screen for his presentation, just a reminder to our live participants, if you have questions, feel free to type in the chat. At the end, I will also allow everyone to unmute yourself, and so feel free, if you have a microphone, you can ask your questions after today's presentation. The chat box for those that are new to Zoom is located either at the bottom of your screen or top of your screen, depending on which type of computer platform you are using. So Dr. Koelsch, I can see your slide, and so I'll turn it over to you to get started with today's presentation.
Well, thanks Kim for that kind introduction. I should have you remove some of those dates. They make me be a lot older than I really think I should be, but I guess I have to live with that. Hi to Karen and Samantha and Leslie. Glad you could join us today. Looks like we might have a small group, which when you're talking manure, that's kind of the case many times, but I'm very glad to have a chance to visit with you. You know, with a small group like we have today, if you want to just unmute your microphone, and as we visit about some topics here today, I'd certainly welcome questions right at the time. Certainly, if there's a topic that is of greater interest to you, we can spend a few more minutes on that before we move on. So since it is a small group, please feel free to speak up, and we don't have to follow the exact agenda that I had originally planned for us. I'm going to move us to this slide here. I like to start with this just as a reminder of some of the challenges from an environmental perspective that we face in the animal industry, and a lot of them relate to nutrients and our ability to manage nutrients. If we think about it, we move a lot of nutrients from our crop production, our animal feed production to our dairy cattle. And those dairy cattle are only going to recover 25, maybe 30% of that nitrogen and phosphorus. And that other 75% can challenge us in many ways. And so how we manage that other 75% of the nitrogen and phosphorus has a lot to do with our impact, especially in the water quality area and in some respects in air quality. So a lot has happened over the last 20 years to try to improve this. A lot of it has been done through regulations, and a lot of it's been done through just improvements in our industry in terms of how they value that manure. I think in terms of my own generation, where we had fairly easy access to the fertilizer nutrients for many of our crop nutrient needs. And we treated manure for the most part as a waste. But I think in today's environment, we really need to be thinking how we're going to recycle that nutrients as efficiently and as effectively as possible. And I think our biggest challenge today is deciding, when we have access to those manure nutrients, whether we're going to turn to the manure nutrients that already exist within our rural communities, or whether we're going to import fertilizer, commercial nutrients from outside the region. And that decision is sometimes regulated for those farms that are regulated, but as we move more and more of that manure nutrients off farm to neighboring farms, that's often a choice of which product, fertilizer or manure, is going to provide the greatest value. And so this question of which product we're going to use is really going to be, in many questions, a question of value. And so today we thought we would have a discussion around the value of manure. And as you're having that conversation with, about fields that you manage or with neighbors who might be utilizing your manure, that you have the ability to define that value of manure. So let's start with that discussion around what is the value of manure. And I would be remiss to say that, manure has two sides to it. There is a side of significant value, which will be the focus today, but there's a lot of challenges that come with manure. And we're going to leave that topic for some other times in the future, but we're going to focus today on the value. And I always like to start with this story. Leslie's heard me tell this one before, so she can actually speak up and share this with you. But, manure has been valued differently over the years. In the 17th, 18th century, Europe valued manure very much, so much so that it was actually transported often by ship from one country to another, because that was the primary source of nutrients available for growing the crops that they produced in Europe. There was only one problem that resulted, though, from some of that transfer of manure from one country to another by those wooden ships, is some of those wooden ships leaked a little bit in time, and manure combined with water can create some challenges, such as the production of methane gas. and the captain would occasionally send one of those lowly sailors down to check the holds with their oil lantern, walk into a place where the methane had accumulated and caused the ship to blow up. And so there was a problem with ships transporting manure and their ability to keep them from blowing up. And one of the solutions to that problem, we are told, is that packages or crates with manure in were often labeled stow high in transport, which using the shortened version of SHIT is an acronym that I often get myself in trouble with. So just as a way to start off our discussion about the value of manure, just remember that the origin of that word had a different connotation at one time. Okay, let's talk in terms of the value of manure. And I generally like to visit about three aspects: the agronomic value, the value of the nutrients in the manure, the value of manure to soil health, and that's the value that comes from the carbon in manure that doesn't exist in other fertilizers. And then I will suggest to you that there may be a water quality value. Not all of you may believe that, but just we'll get to visit about that here in a second. So let's just start with the discussion around the agronomic value of manure. And let's see, I know our group is small, but I'd like to get you to interact with me just a little bit. I think at the bottom of your screen, you have a means of a button that allows you to, what is that called, Kim, to raise your hand or to put a thumbs up. I'm not seeing it on mine right now.
So this isn't set up as a webinar, so to say, within the system, and so they're not going to have those options.
They're not going to have that. Okay.
Maybe if they have a button that says reaction, they can give a thumbs up.
Yeah, that's what I was looking for, that reaction. So if there's a thumbs up, I see a couple of thumbs up, people agreeing that manure has an agronomic value. Looks like, come on, Leslie, I need you on my side here too. So I hope you'll give me a thumbs up. Okay, so I think most of us would agree that manure has an agronomic value. And let me just put up a couple of visuals for couple different sources of manure that we often deal with in our dairies. This is some manure a sample that came out of a flushed dairy barn, lower solids. And this is one that came from more of a slurry system, a scraper system, the higher solids. And as you look at the different values to that manure, and it's fairly easy to put these numbers on it, you can see the magnitude is different in terms of dollars per 1,000 gallons, because we're dealing with more water in one circumstance than the other. But the relative contributions are roughly the same. You know, the nitrogen's about 1/3 of the value, the potassium's about 1/3 to 1/4 of the value. Phosphorus is also important. There's the potential for a yield increase. We'll talk a little bit more about this. I just assumed roughly a 5% increase in yield, and that contributed about 7 or 10% of the value of these two totals. So you can see that the contributions for the different sources of nutrients are fairly similar, both products. One's going to have a higher value just because things are more concentrated. Now, this is a potential value. And we need to be thinking in terms of what is the actual value of these constituents to an individual field. So I'd like to take that information and now apply it to this situation where we've got a dairy farm that has a choice of shipping manure to 4 different fields. And if we were to ask what's important for us to know in deciding what the value of the manure is in one field versus another, what would be those important things? And hope you might open your chat box. I'm trying to see, here's my chat box, I want to open it. If If you type into your chat box or turn your microphone to on and speak up, I'd sure appreciate hearing what would be something you would use to say, to ask the question, what's the value of the manure at one field versus another? Any thoughts there? Distance. There you go. Thank you, Karen. Excellent. Current soil nutrient levels. Okay, excellent. I think we're on the right track. Now, I'm going to think in terms of value, so I'm going to be talking about more about Samantha's idea here. Distance is more of a cost, and that we're going to leave to another day. So let's think in terms of some of the ideas that Samantha has put up. Crops, Kim, that would be another one. So I'm going to put up my first two things here. Here we go. Crops would be certainly the first thing I would ask. And so for those 4 fields, you can see that, soybeans, we would not generally add nitrogen to that field. So we know we're not going to get any nitrogen value from that soybean field. But corn is going to need a nitrogen value as well as other nutrients. So that begins to do an initial sorting. Probably more importantly is the soil test level that Samantha had mentioned. And what is that soil test level versus the threshold at which we get some agronomic value from those nutrients? So I popped into those information boxes for those 4 fields a soil test for potassium, or phosphorus, and for potassium. Now for phosphorus, there's value when we're in that range of a braze soil test of somewhere in that 15 to 30 parts per million, probably closer to that 15 to 20 for corn, probably up in that 30 part per million for wheat. So you can see we're well above that on field A, so no value is going to come from the phosphorus. Field B, C, or B here, C and D, all might get some phosphorus value because they're pretty much close to those thresholds or they're below it in the case of that wheat field. For potassium, for most crops in Nebraska, we'll use a value of 125 parts per million. So fields A, B, and C all are well above that. So there's not going to be any value to that potassium. But we can get some value from field D out of the potassium because it's below that threshold. So fields that are near or below that threshold are the ones that are going to give value to potassium and phosphorus. And the same could be said for sulfur and others that we're not going to get into today. So once we have those 2 pieces of information, we can start putting values of the manure to the individual fields. Field A, there's no value. So we've managed the manure as a waste there. Field B, and I'm using that manure that from the flushed barn, would have a value of $230 per acre. But in order to supply that value, I've got to transport roughly 20,000 gallons per acre, which got to, I believe that was, might have been Karen's comment about the distance to haul. So moving 20,000 gallons to the acre would be the cost. There would be a cost with that. This wheat field over here, probably not going to put on as much, maybe more in the 10,000 gallon per acre range. We get roughly half that value. Field D, because it has value from all 3 of those nutrient sources, is going to have another $100 in value over B. So each field has a different value to the manure. And it's important for us to walk through those calculations. Then we can decide, can I afford to transport manure from field A on down the road another 1.5 miles to field B for that $230 per acre value? Or further yet, another mile and a half to get that $330 an acre. And so now we've got to enter that cost of transporting. Now, if I was to use that higher, more concentrated manure, I'd only have to get 6,000 to 7,000 gallons delivered, and my cost would be different. So my answers to these questions might be different, whether I'm using that more diluted manure or that more concentrated manure. But it starts by estimating the total value of the manure and then deciding what is actually going to deliver value in terms of those different sources that we saw in the previous graph. So I would suggest that if you're interested in the value of manure, it's important to go through the calculation, first of the total value, and we do have a spreadsheet I'll point you to at the end for doing this. It's about a 5-minute example if you have a manure sample and you know the cost of the fertilizer nutrients. And it can quickly lead you to a value of, in this case, $280 per acre. And then you can decide, can I afford to move that manure to that site or not? So that gives you the total potential value. And then you have to go through the process of looking at the soil test and deciding, is there value to be gained from the nitrogen, the phosphorus, the potassium, and other nutrients? So let's get back to maybe just some generalities in terms of which fields are going to give you the most value. I typically focus people to look at the phosphorus first. Now, that wasn't the biggest part of that pie that we originally saw, but there's such a variability in phosphorus in fields around our animal feeding operations. And so it's sometimes you don't have to go very much further to find a field that is not high in phosphorus, is at or below those thresholds. And by targeting those fields, that's often the place I can often add significant value to the manure. So I often tend to look at phosphorus first. I sometimes will look at fields that have a higher threshold, such as wheat. So that sometimes gives me some additional value. And in case of your dairy operations, those fields that are using a lot of phosphorus, such as corn silage or irrigated alfalfa, can often add value to it. Now, typically when we apply manure to meet closer to our nitrogen needs, we're often over applying that phosphorus. And so to get that true value out of that phosphorus, sometimes I'll need to delay returning to that field until I see those phosphorus levels on my soil test down in that 15 to 30 part per million. So I tend to start phosphorus in most cases. Now, for our solid manures, I tend to look at potassium next because they tend to provide a lot of value in potassium. For our slurry and our liquid manures, I tend to look at fields that are going to need nitrogen because they tend to have a lot of nitrogen readily available in that ammonium form plus organic nitrogen. And so that combination tends to focus me in that direction. Okay. A part of this value can come from yield increases. Just want to share one piece of research rather quickly here. This comes from a report that has summarized results of 141 different trials of manure versus fertilizer, and where they were applied equally on a nitrogen basis. And I'm just going to look at the crop increase yield that came out of that report. On average, on those 141 trials, 5% of the crops, a 5% increase was seen in all crops. 9% was seen in terms of corn. And then I think one of the most interesting parts of this, and this was confirmed by another study of about 400 different trials, is that our largest increase of yield has been seen where we are using manure and fertilizer in complementary roles in a fertility program. And those numbers have been in the range of 10 to 20%. So I think we can really increase the value of fertility value of manure when we think about using manure and fertilizer together. Just a thought for your consideration. Okay, second value, soil health value. Is there value to manure from a soil health perspective? Thumbs up, thumbs down, yes or no in the chat box, whichever is easiest. What do you think? See a lot of thumbs up coming up here, good. And I think most people recognize that. Even our neighboring crop farmers have seen that in different circumstances. But what is the value of that, I guess? Let's talk a little bit about it. I've typically thought in terms of manure improving the physical properties of soil. But I really think the true value of manure is in the biological properties, what's going on inside that soil. And that does impact the soil physical properties. I like to think of manure, it's like taking your teenager to a Valentino's buffet. It provides a tremendous energy source for all of that biology that's going on in the soil. And it rapidly ramps up that biology. And that is what is producing most of the short as well as the long-term benefits to soil health that result from manure. And is that sudden jump in biology. There's an article, an extension article that Michigan State has written that is very well done on manure's effects on soil biology. And I'll just pull out one quote. When manure is added to the soil, it quickly is colonized by millions of bacteria. Bacteria produce large quantities of polysaccharides. These polysaccharides serve as the sticky glue in the soil that forms particles into aggregates. And that physical change from that biology is so very important to the quality of our soils, especially our tighter texture soils. And I'm going to share just a very brief summary of one example of this from research here in Nebraska. This was work done by Charles Wortman a little more than a decade ago. It was a series of plots they set up that they could monitor all the runoff and the erosion from plots that were receiving manure and then being fertilized comparably with just commercial fertilizer. They did it with feedlot manure for 3 years at a nitrogen-based rate. They monitored the fields both for those 3 years and then 4 years after they quit manure application. And in the 3 years that manure was applied, look at the difference in the sediment loss and the runoff from these two fields, the composted versus the commercially fertilized. That significant reduction in runoff and erosion is due to those soil aggregates. An aggregated soil particle is less likely to erode. It's more likely to let moisture soak into the soil and be retained in the soil profile. But one of the more interesting things is they watched this for 4 years afterwards. And this next graphic that pops up is that residual effect. So over those next 4 years, when manure was not applied, there is those residual benefits still in existence. And I think that biology that goes on from where we add manure that impacts some of the physical properties is probably the most important short-term benefit, and probably in many cases one of the contributors to the yield increase that we often see with manure. So just recognize there is a benefit. Which soils, which fields benefit? Here's some of the things I tend to look for. I tend to target our finer texture soils because of their short-term benefits that we see. You know, a benefit that results from this year's manure application being seen this year. I tend to target fields that for some reason, maybe due to past tillage or whatever, are lower in organic matter, fields that tend to crust over. I've had several farmers, crop farmers, in fact, tell me that they tend to target fields that experience ponding and drown out spots And manure applied on those fields tends to reduce or eliminate those in short order. Again, back to those changes in the physical properties. So those are some of the fields I tend to target as getting the greatest soil health benefit from manure. I know our time is getting on the short side here, Kim. Do I have a couple more minutes, or would you like me to put her a stop here?
You can continue going.
Okay, we'll try to wrap this up quickly here. Is there a water quality benefit from manure? Thumbs up, thumbs down, don't know. Any thoughts here? It's a photograph I took about 25 years ago on a dairy farm I was working with when I worked with Extension in New York. You can see that there was looks like a water quality risk associated with this dairy farm. I saw a thumbs up there. I'm guessing many of us are waffling on this question. We've seen history where manure is treated as a water quality concern. But I'd like to suggest, my slides won't move forward here. Okay, that there's a water quality benefit. And I'm going to go back to this same study that we mentioned earlier. They looked at the water quality results from those comparable studies and the nitrogen losses from those studied plots, and look at ammonia nitrogen that went into the air, dropped, nitrates in the runoff, surface water, and in the groundwater, all reduced. Now that doesn't quite match with kind of our historical view that manures are a water quality risk. And so why might this be true? And again, it's back to the biology that's going on in this soil. The same study measured what was the difference in the microbial biomass nitrogen pool that's in the soil. And they found that the nitrogen was being stored in this microbial biomass. And microbes don't move, they don't leach, they don't run off like particles of soil. So because we're storing that nitrogen in what was nature's slow release form of nitrogen rather than in this ammonium or nitrate form that we know has a greater tendency to move on us, that factor is why they believe they were seeing less nitrogen in the runoff and in the leaching. But all of that requires, and I'm going to skip by this, all of that, for that benefit to be seen, there we go, it requires that manure be applied at agronomic rates. And so that study was comparing an agronomic rate of manure versus an agronomic rate of fertilizer. And in general, I would say our risk with manure is lower from manure than fertilizer because of the forms of nitrogen that nitrogen is stored in. And also from the reduced erosion, the reduced runoff that we've seen previously. If we apply manure as a waste, then we all have to agree that it is a water quality risk. It's worse than our commercial fertilizers. So we have to remind ourselves, are we going to treat this as a waste or worth? Last message I'd like to just share with you, and only going to share a part of it. Over the last 5 years, I've had a lot of opportunity to work with a couple of organizations that have gotten very much into sustainable production in agriculture from a supply chain perspective. And so this is a bonding of our animal agriculture groups with the McDonald's and with the Tysons and with the Cargills, and deciding what sustainable agriculture looks like. And in all of those discussions with the Tysons and the McDonald's, you hear a lot of discussion about how we're trying to create this circular economy, how important this circular economy is, whether it's managing plastic at McDonald's or it's in a variety of other circumstances, how they're trying to recycle various products, plastics, aluminum, and so forth. Well, I like to remind people we've been doing that for generations. But we sometimes have to ask ourselves, how well are we doing in this part of that recycling of manure back to the soils and the crops, back into animal feeds, and then back to the animals? So our ability to recycle this manure efficiently is a very important story if we want to say we are a circular economy. We are the original, some of the original recyclers of nitrogen, phosphorus, and carbon. So our decisions we make over here in that the manure and the soil side of this equation, I think are extremely important. It's very fundamental to our ability to say that we're good stewards of the environment. This slide next, I'm going to drop through this quickly. It's another point I'd like to make, but at another time. So I'd like to conclude with a few messages I hope you'll share, be thinking more for yourselves, and also be sharing with your neighbors in your community, with your zoning boards, with people that make decisions in your community about animal agriculture and the future of animal agriculture. The first thing we need to remind ourselves is, are we recycling local nutrients like manure before we're importing outside nutrients like fertilizer? And really that is a part of this circular economy we're trying to create, just like we're trying to create in managing aluminum and newspapers and plastics. So this is our way of creating that circular economy that is part of our sustainability. How we value manure and how we identify soils and fields that are going to give us the greatest value for manure, I think is important in deciding whether we're going to end up using manure on a field or we're going to end up using fertilizer or some combination. So I hope you've got some ideas you've taken away from in terms of the value of manure. And then finally, I'd like you to be thinking in terms of sharing the positive things that you're doing where you're managing manure as a resource, not as a waste. I think anytime you're managing manure as a resource, the ways that you're doing it, that is an important story for talking with your neighbors about, talking with zoning boards and others that are in those influential decision-making places. So I think that's pretty much my story for today. Here are some references if you would like to access and do the calculation, let's say, for the value of manure and crop production, or some other resources that I've mentioned during the day. And if you want access to this slide, I guess, well, maybe I'll jump back to my very first slide because that gave you access to my notes. You probably didn't have time to go through all of that. So I think that's where I'm going to stop, Kim. See if there's any questions that people would like to ask, and I'll bring up that first slide that has the link where you can get access to this. Questions or comments, things you'd like to share. I dumped my load on you. You should have a few minutes to dump your load on me here.
Feel free to unmute yourself or type in the chat also. And while participants are typing their questions, I do have a couple questions, Rick, that I noted as you were presenting. One thing I missed or I'm not too familiar with is the level of application. So how do you know how heavy to apply the manure to the different fields? Like once you determine the field that you're going to apply to, how do you determine that application rate?
Okay. Historically, it's kind of a two-step process. First, I typically want to never apply manure more than the manure and fertilizer I might use more than the nitrogen requirement of the crop. So I'll look at the nitrogen characteristics of that manure, and if I need 100 pounds of nitrogen to supplement that crop need, I will look at how much manure I can apply to credit that 100 pounds of nitrogen and not go over that. Nitrogen is something we have to manage on a single year basis. We can't leave excess nitrogen because it's so likely to leach or move away from that field on us before the next season. The second step is, when do I return to that same field and reapply manure? So it's possible that when I applied manure at my nitrogen rate, I've got more phosphorus there than I need. Phosphorus is something we can manage over several years. And so if I monitor that soil phosphorus level next year, 2 years from now, and I see that soil phosphorus level returning to that 15 to 30 part per million range, then it's time that I can come back and reapply manure to that field.
And then a question in the chat. Rick, thanks for your presentation. Can a farmer sell conventional manure for use in an organic row crop operation?
And that is a question I get different answers from, depending upon who is watching over that organic system and certifying it as organic. So you almost have to go back to visit with that organic farmer and the individual that is certifying that piece of land as being organic. And I'm not sure I fully understand what are the circumstances at which it is or is not being classified as organic. I know I visited here recently with a poultry producer that was selling his poultry litter, including his use of the antibiotics in the poultry animals, in the broilers. He was selling his manure to a farm 40 miles away that was using it for organic production. And I've heard it's similar circumstances where did not work. So I can't answer that. I think you need to go to the individual certifying the piece of land and visit with them about what they're willing to accept and what they're not. Glad to stick around and answer any other questions that might pop up. If people have other things to get to, certainly understand that. We all have busy schedules. But thank you for joining us and talking manure with me for 30 minutes here. I don't often get that opportunity, Kim.
Yes, this has been great. We'll hang around for a couple more minutes. I do want to mention our new podcast that we have, our I-29 Moo University Dairy Consortium has a podcast that we started a couple months ago, and the 1st and 15th of every month a new podcast episode is published, and in your podcast platform you can search I-29 Moo U, and our podcast will come up. Some of the topics that we have delivered so far include heat stress, managing heat stress, feeding strategies to avoid overfeeding and acidosis, animal activism and how to talk to employees regarding animal activism. The next one that we're going to publish is on silage safety. So great podcasts that you can reference anytime in the tractor, in your vehicle, while you're out doing chores. So I encourage you to download our new podcast. Just a note in the chat, Rick, thank you for the presentation and all of the great information you shared.
Yeah, I've enjoyed the opportunity to be with you folks. And I think Karen has popped off. She asked a little bit about distance to haul early on. I think, Kim, in 2 or 3 months, you and I are visiting again, and we're going to talk about manure more from the challenges side. And one of those challenges is the cost of moving manure. We'll be talking about that and other challenges at that time. So look forward to having that conversation in the future.
Great reminder, Rick. Yes, we will be continuing our manure discussion. Next month, we're going to talk about manure handling and application safety reminders. That's in September. And then in October, Rick is joining us again, and we'll be talking about some of the challenges of manure. Thank you everyone for joining us today. We look forward to having you join us for next month's presentation, September 11th, same time, 11 a.m. Central. If you have any questions in the meantime or ideas or topics for future webinars, feel free to type in the chat or even send me an email at kimclark@unl.edu.